Around the 6th century BCE, Egypt stood as the center of science and architecture in the ancient world. The pyramids towered high, symbols of both grandeur and mystery. Yet no one truly knew how to measure the height of these colossal structures without tools or climbing to their peaks. Then came Thales of Miletus, a thinker from Greece. He was no magician, no priest, and no architect, but a devoted observer of nature. During his visit to Egypt, Thales watched sunlight, the Earth's surface, and the shadows of objects with extraordinary curiosity. He began to ask, "Can the length of a shadow tell us the height of an object?" That simple question became the spark of a revolution in human thought. In a land that regarded the pyramids as sacred, Thales saw them instead as objects of scientific observation. He believed that sunlight created measurable patterns, and that shadows were not mere phenomena, but data from nature. With a small stick and sharp reasoning, he would prove that human intellect could rival the mysteries of the gods. Under the blazing noon sun, Thales planted a wooden stick into the ground. He watched as its shadow shifted with the sun's movement. He noted the time, position, and ratio between the stick and its shadow. From these observations, he discovered a pattern. When the sun reached a certain angle, the length of a shadow was directly proportional to the height of the object. This simple principle would later be known as geometric proportion. To prove his idea, Thales waited until the moment when the length of the stick's shadow equaled the height of the stick itself. At that same instant, he measured the shadow cast by the pyramid. From that comparison, he concluded, the height of the pyramid equals the length of its shadow at this moment. This method allowed for accurate measurement without ever touching the monument. To the Egyptian priests, it seemed like magic, but to Thales, it was simply logical observation. He had just demonstrated that the sun could be the most perfect measuring tool in the world. Thales did not stop at one experiment. He began to formalize mathematical rules from the phenomenon. He realized that every object illuminated by the same light source would form similar triangles between their heights and shadows. That meant that if two objects received sunlight at the same time, the ratio between their height and shadow would be identical. This is what we now call the theorem of similar triangles, one of the foundations of Euclidean geometry. Through this concept, Thales expanded humanity's understanding of space and form. He proved that nature could be explained by ratio and logic, not by ritual or superstition. The method he used to measure the pyramid was merely a small example of a greater way of thinking. Every natural phenomenon has a mathematical law behind it. This simple principle paved the way for experimental science and modern measurement techniques. For the Egyptians, the pyramid was sacred, a symbol connecting earth and sky. Measuring it was seen as an act that defied divine order. But Thales viewed it differently, not as blasphemy, but as an attempt to understand nature rationally. When he explained his discovery, some priests looked at him with suspicion. They were used to linking the pyramid's height to divine power, not to sunlight. Yet, when Thales's measurement matched the architect's own estimates, they began to realize that human reason could indeed read the laws of the gods. For Thales, this was proof that knowledge transcended nations and beliefs. He wasn't challenging faith, he was freeing the mind from the fear of mystery. Through logic and observation, he changed how humanity saw the world. Thales realized that the pattern he found in shadows applied not only to pyramids, but to all of nature. Light, distance, and form possessed order that could be expressed in numbers. This was the dawn of systematic scientific thought. To him, nature was not a realm of chaotic divine forces, but a rational system governed by laws. He applied the same principles to understand the motion of stars, the tides, and the changing seasons. With a single measurement in Egypt, Thales was laying the foundation for the exact sciences. He proved that observation and logic could answer questions once left to myth. From that small act, the tradition of scientific inquiry was born, a tradition later carried on by his students in Greece. After studying various techniques in Egypt, Thales returned to Miletus, a prosperous Greek port city. There, he began teaching methods of measurement and logical reasoning to his students. He explained how one experiment in the desert could reveal universal laws. He said, "We need not pray to the gods to understand the world. We only need to observe and think." From his teachings emerged the Milesian school, the first scientific learning center in the Western world. The principles of systematic observation, logical proof, and natural causation became the foundations of all later sciences. To his students, the story of how their teacher measured the pyramid was merely an example of a greater way of thinking, one that rejected chance and sought order. Thales' discovery about shadows became the basis of applied geometry. His method was used to measure distances, tower heights, and even the width of rivers without crossing them. Centuries later, scientists like Euclid and Aristotle expanded upon his concepts into complete mathematical systems. They hailed Thales as the pioneer of geometric logic, the first to prove theories through deduction and rational reasoning. From a stick and a ray of sunlight was born the science of measurement we still use today. From architecture to civil engineering, Thales may not have fully realized it, but his method marked the beginning of experimental mathematics. To some, the story of Thales in Egypt is just an ancient legend, but to the world of knowledge, it symbolizes the power of the human mind. He showed that even a simple shadow could be the key to understanding the laws of nature. Thales proved that there is no boundary between observation and great discovery, as long as one dares to ask and to think critically. The Egyptians may have built their pyramids from stone, but Thales built a pyramid of knowledge from logic and observation, a legacy far more enduring than any monument. Every great science begins with a simple question. For Thales, that question was, how can we measure the height of a pyramid without climbing it? The answer he found was not merely a practical solution, but a new way of thinking. He replaced myth with observation, wonder with logic. From a shadow in the sand, he revealed that ratios and angles could explain the world. That discovery marked one of the greatest shifts in human history, from an age of belief to an age of reason. And it all began with a single stick standing beneath the Egyptian sun. More than 2 millennia later, Thales' name endures in every book of mathematics and astronomy. He left no palace, no treasure, no army, but a way of thinking that transformed the world. His method of measuring, the pyramid, was just one example of how true knowledge arises from simple observation and the courage to think. From ancient Egypt, that idea spread to Greece and then to the entire world. Now, every time we calculate distance, measure height, or study patterns of light, we retrace Thales' footsteps in the hot sands of Egypt. A shadow is but another form of knowledge, wrote a later philosopher. And Thales was the first who dared to measure it. That legacy was never buried with the pyramids. It lives on in every formula, every experiment, and every human being who believes that logic can unveil the secrets of the universe.